Math 76, lesson 110, symmetry, right? So we're continuing our work on some geometric math facts, and today our studies of the word symmetry, okay? Now symmetry more or less means that if you were to cut the figure in half, both sides would be perfect mirror images of each other, or they would be like copies of each other. So the fastest way I can show you symmetry is, well, actually I'm going to use a note card. Look a little bit smaller. Right? If I were to take a note card, right, to make this symmetric, whoops, that's 2 note cards. Whoa, magic. No, I'm just kidding. That was an accident. All right, to see if this is symmetric, I could try to fold it in half, right? So if I line those corners up and I go to fold it, all right. Are both the halves equal? Yeah, the halves are equal. They're perfect mirror images. When I fold them, they line up perfectly, right? So this card is symmetric, and it's also symmetric more than one way. I could have folded it horizontally, and it would still be symmetric, right? So these are called lines of symmetry, right? So I've got a horizontal line of symmetry. I've got a vertical line of symmetry. Now some of you are thinking, wait, let's show you one. Can't you fold it diagonally? Would that also make it symmetrical? Well, let's find out. So let's say I take this rectangle, and how do I, ooh, okay, this is a little tough. Let's see here. I get a fold from there to there. Okay. All right, I have folded it diagonally. Now, is that symmetrical? It's actually not. See, because when I fold this diagonally, it looks like I've got some extra. I've got 2 shapes. Whereas when I folded it vertically, it looked like one shape, but it's the same on each side. When I fold it horizontally, same story, one shape, and it's perfectly mirrored. However, when I fold it this way, it's not perfectly mirrored. The corners end up on opposite sides. So this diagonal line is not a line of symmetry. And if I were to fold it the other diagonal way, it would also not be a line of symmetry. Okay, so that's how symmetry works. Symmetry has to be perfectly mirrored. Or another way to think of symmetry, let's go back to my example triangles. A symmetrical shape, if you were to reflect it, would create a mirror, or not reflect it, what's the word? Yeah, no, it is a reflection. It would create a reflection, right? It would reflect perfectly, like if we were to turn the shape over. That's what a line of symmetry would do, right? Now, a line of symmetry would not turn into that, okay? So that's how we can catch lines of symmetry. So let's do an example. They say example 2, which of these triangles does not appear to be symmetrical? So the best way we can test this is we can just start drawing some lines through them. Now, I don't encourage you to do this on your textbook, but on some of these problems you may have to. So if you do have to draw on your textbook, just do it lightly in pencil, and then make sure you erase it when you're done. So if I look at A and I want to make it symmetrical, the first thing that comes to my mind is, what if I cut it vertically? Right? If I were to cut it vertically, yeah, that does make that's symmetric, because it cuts it into 2 perfectly mirrored shapes. So that one is a yes. I could have also cut it this way, or I could have cut it this way. This one could have had 3 lines of symmetry in it. So that one is symmetrical. So A is symmetrical. I'm going to go ahead and write down my answer, yes, and then erase the lines. What about B? Well, if I draw, nope, that's not symmetric. Any other way I could do this? What if I draw from this one? Nope, that would not work. Oh, wait, what if I drew that way? That would be symmetric, okay? And maybe you guys are starting to catch on to the method I'm using. The method I'm using is I'm going to vertexes, right? And I'm trying to draw a line to the opposite side of the shape from the vertexes to see if it's symmetric. Now, if I couldn't find any with the vertexes, then I would go to the sides, all right? So I'd go halfway between this side, try to draw a line. Oh, that one doesn't work, okay? So then I would go halfway across this side, draw a line. Oh, that doesn't work. Oh, but what if I go halfway along this line and draw a side to, oh, that does work, okay? So those are the 2 methods we can use to find symmetry. You can go to a vertex and try to draw a line that would cut it in half, test every vertex for that, or you could go halfway into one of the sides and try to draw a line that would cut it in half, and that's the other way we could test it. All right, let's look at this last one. If I try the vertex, no, no, no. What if I try the halfway? No, no. No, yep, nope, C is not symmetrical at all. Doesn't matter if I choose every vertex or every side, no symmetry in letter C. All right, let's see here. Nope, that's it for this lesson. Oh wait, no, one last quick trick question, as it were. Let me find, hold on, let me pause the video so I can set this up. Okay, last shape. Now I have a square, right? Why would I test the square? Well, if you remember with the rectangle, we could fold it vertically, we could fold it horizontally, but diagonally did not work, right? Because the pieces didn't match up, they didn't mirror perfectly, right? So with a square, it looks like I can fold it horizontally. Yep, that worked. I can fold it vertically, so that's 2 lines of symmetry right there that I found, right? And then what about diagonally? Well, let's try to fold the square diagonally and see what happens. Okay, what's that? If you fold the square diagonally, you still get some perfectly symmetrical triangles, right? And I could also do that with the other diagonal. So if you were to fold the square diagonally, you actually end up with symmetrical triangles. So what I want you guys to think about is, before the next class, think about why that works for a square but not for a triangle. And that's it for this lesson on symmetry. If you guys have any questions, let me know in class, and I will see you then.